would like to pass the time to our ground station master Xiaoyu to let you to further elaborate.
Actually, in the ground station, we also have we design a keypad. We can enter for example, you enter a position. I want, for example, I want the satellite to, for example, I want to put in Japan, you see, and so you see, if I enter, I give orientation to the satellite, and it will point to Japan as we designed. And also, we have a ground station. We can get the feedback from the satellite, and so we can sense the satellite.
Sorry, it's not that smart yet. If you want to change another position.
Okay, so actually we have many countries here. Which country do you like? Maybe you can give me a country and I can point you.
This is Thailand, right? Okay, why not Thailand? Okay, Thailand.
So even if Daniel is blocking Thailand,
so it's
looking at
no, there's still Malaysia.
Okay, Malaysia. Want to try Malaysia?
Malaysian. Australia?
oh, Australia.
Okay, and also we can go to Singapore again.
Let's go back to China first. let's demonstrate all the stations first.
We missed China.
A panda is there.
Why is it looking this way?
Okay, now go back to Singapore. Okay, because it's like we are going around to gather data from other stations, and currently it go back
because
to
it's not in manual control, so depends from outside or not. Then we can go back to.
Okay, let's go back to the automatic control. Okay, in automatic control, right, you can see it's station from the GUI again. And the pin like to give us some external disturbance.
Go back to the ordinal.
Yeah, because the first.
What is the degree of freedom here? 90 plus 90 minus 90.
Yeah, because we are using a servo, so maximum is like 180 degrees. So we use its middle as a 0, so can rotate positive 90 and negative 90 to both directions. Then the whole process will continue and continue until the end of the lifespan of the nanosatellite. Yeah, that's the end of our presentation. Any questions?
Yeah. So if you remove your Kalman filter algorithm, how it will be like?
If we
remove the Kalman filter.
remove the
Disable
Right, we use three sensors here, right? And we use the gyro as a major component to determine the orientation, but we need to use the accelerometer or magnetometer to compensate the drift.
So you use accelerometer?
Yeah, so we need to use the Kalman filter to combine the data from these two together. If we don't use that, we need to choose either one from these three sensors.
But did you observe how it will be without the Kalman?
Yeah.
Actually, we also try, for example, we use only 2 sensors and we don't use computer. Actually, the 3D animation will tell us and after a long time, for example, if after a long time, the desired position will change a lot. So actually we use Kalman filter to make sure the accuracy of the
What will be the state if we don't use Kalman filter?
For example, then we use the gyro, right? Then suppose the original position is here, and after a long time, maybe you will go back to here. Go to here. The satellite will go to here because the data will drift. That means the error will increase, accumulate. Yeah, because at first, suppose the error turn right is 0.1, then after a long time, maybe become 5 already.
So you're saying Kalman filter is used to remove the drift?
Yeah, to cooperate the accelerometer and the gyro together to remove the drift problem.
Actually, remove the drift is because of another sensor. But if because 2 different data you see the raw data, when you combine together, you must make sure, for example, calibration to make them function together to make sure what you want.
You know, why I'm asking is like, if you use a raw accelerometer in your iPhone, it will be highly shaking like this.
Yeah.
You know, so like, if you do, just do like this, the information what you get like this. You use command filter, you will be rotating that. That's why it is required. Drift, you need to have something else to really compensate for.
Yeah.
You can use command filter to really take out the drift. Drift is a different issue. Command filter is for different purpose. You're mixing this up, that's why you got confused.
Actually, if we because we're showing the process, right? Actually, before we try in common filter, because it's a very complex thing. Before we try it, actually we never get the right position of the.
Can you make it manual and make it point to Australia manually?
Sure. Okay, let's go into manual first.
Maybe Australia.
Then can you change back to automatic mode? Will it still point towards Australia? Is it automatic?
No, why it is not looking this way? It was turning that way. Or you might have.
Oh yeah.
We set the angle like that.
So you're using the gyroscope, is it?
Yeah, gyroscope as a meter.
So where is the gyroscope place?
On top.
On top, right?
Okay.
And accelerometer? Accelerometer?
The small sensor.
This is anything over here, right? Good.
So the design position changes actually. So actually, if we want to return to Singapore, we need to enter, for example, going to Singapore again. Then start automatic.
Okay. One most important thing, you should never use this. Using satellite, I got confused.
It's more like a robot.
Oh yeah.
Working easy.
You should have hanged it from the ceiling.
Actually, we come up with this idea from OE. We watched the movie. Yeah.
Wonderful guy.
You see, the ISIS.
So
That's why we designed it. Actually, it's another one.
It's a wall in Excel.
yeah, it's just one thing, two of them one thing.
He is recorded everything.
Yes.
So let us. I would like to have a copy.
Yeah, sure.
Any questions?
Anything else?
No matter.
Thank you everyone for your whole semester getting my help. Really, really thanks. Yeah, especially our project supervisor Daniel and also Rasha. They really spent a lot of time with us.
Because of your project.
Yes.
It's like.
All the best. Thank you.
Thank you. Thank you. Thank you.